Hello students, welcome to the channel Campedia. Today we will be recording a lecture on the topic hybridization. We will be learning hybridization, the types of hybridization and the importance of the hybridization. We know this is the important topic of the chapter chemical bonding. Chemical bonding, we have studied that why do elements combine, uh, for what reason elements do combine, how do molecules are formed. All these things are the part of the chapter chemical bonding. In the process, we are going to study about the topic hybridization. What hybridization is, what are the types of hybridization, and what are the geometries related to the hybridization. Importance of the hybridization. So let's start with the topic hybridization. Let us understand the definition about the hybridization. What hybridization is? Hybridization is the intermixing of the orbitals of different energy in order to get the orbitals of the same energy. Okay, means you've studied that there are certain kinds of orbital as p orbital, d orbital, f orbital. They have their own shape, dumbbell shape, double shape. All these things we have studied. So according to this, if they have different shapes, if they have different structures, they do possess different kinds of energies. And when they do possess different kinds of energies, we will they will also be less stable. But if they have the same energy, then they will be considered as a stable molecule. So what hybridization is? Hybridization is the hybridization is the hybridization is the is the intermixing of molecules inter, uh, intermixing of orbitals of same atom in order to get the orbitals the hybridization is the intermixing of same atoms of of different energies in order to get the orbitals of same or energy similar energy. This is called as hybridization. Now, when you're studying the hybridization, there's some set of rules for the hybridization. There's some conditions for the hybridization. In this process, we will be studying the condition of the hybridization. What are the conditions for the hybridization? Let us understand the conditions for the hybridization. The first condition is the first condition is the first condition is that the number of orbitals combining will always be equal to the number of hybrid orbitals. जितने ज्यादा जितने ऑर्बिटल्स कंबाइन हो रहे हैं अलग अलग एटम के उसके ही उतने ही हमें हाइब्रिड ऑर्बिटल्स मिलेंगे. सेकंड वन, it involves the orbitals it involves the empty orbitals, half filled orbitals and completely filled orbitals. Third condition is it involves the intermixing involves the intermixing involves the is always the intermixing always takes place. The intermixing always takes place with sigma bond or lone pair of electrons or lone pair of electrons. Number 4, the hybrid orbitals. The hybrid orbitals are named after their parent atom. After their parent atom. So, 4 rules. The fifth one is when I said that hybrid orbitals are named after their parent atom. So, uh, uh, if S is the parent atom, we will discuss it later on. Okay? The hybrid orbitals have the hybrid orbitals have their own shape. They have their own shape. अब यदि ऐसा कुछ बना है, somewhat it is made like this, somewhat it is made like this, somewhat it is made like this. It is called a small loop, and it is the larger loop. If somewhere in the diagram in your books it is, if it is mentioned like this, somewhat like this, means the process of hybridization has taken place in a particular uh, geometry, right? So the hybrid orbitals have their own shape. Next one is next conditions are next one we will be studying about. When I said that it involves the sigma electron, it involves the lone pair of the electrons. It similarly means that it does not involve the pi electrons. It does not involve the pi electrons. ठीक. Another one, another example is the if let's see the types of let's see the types of hybridization. Let's see the types of hybridization. We have the types of hybridization. One more law was there. One law was there. It was that uh, during intermixing of orbitals, during intermixing of orbitals, during intermixing of orbitals, there is proper excitation of electron from the orbit from the orbital from the orbital means if there is suppose if there is a condition, we have 1 2 3 electron here, then if you want to form a certain molecule, then there would be the excitation of the electron. This electron will get excite, there would be the excitation of the electron, and what will happen, this electron will be going here. This is called as excitation of the electron. Why is excitation important? Excitation is important in order to get the stable molecule with minimum repulsion. Okay, so these are certain sets of rules for the hybridization. Hybridization, it is the intermixing of the orbitals of same energy of different energies in order to get the orbital of the same energy, stable molecules of the same energy. Let's understand about the types of molecules. Let's learn about the type of hybridization. Types of hybridization. Types of hybridization. Hybridization. One. If one s and one p orbital combine, they form sp hybrid. If one s and two p combine, they form sp2 hybrid orbital. sp2 hybrid. If one s and three p combine, they form sp3 hybrid. If one s and one s 3p combine, they form sp3 hybrid. If one s 2p and 3p and decombines, they form sp3 dihybrid. If one s 3p and 2d combine, they form sp3 d2 hybrid. If one s 3p and 3d combine, they are called as sp3 d3 hybrid. There are other examples. There are other examples also. For example, if there is the filling of d2 orbital, d orbital first, d2 sp3 hybrid are also there. These are inner orbital complex, outer orbital complex, d sp3 hybrid orbitals are also hybrid orbitals are also formed. So these all we will be studying, but before that we will be studying the general types of the hybridization. So let's move on to the example of the hybridization. Hybridization. To understand this, let's take an example. For example, the formation of sp3 hybrid molecule. To understand this, let us take an example. To understand this, let us take an example. Let us take an example. Example number one says that if, let's just take an example. For example, the form sp3 hybrid. Let's take an example of a methane molecule. In methane, carbon have in methane, carbon Z is equal to 1, hydrogen, helium, lithium, boron, ठीक है, beryllium, carbon, He-Li-Bi-Ba, carbon. Z is equal to 6. Electronic configuration 1s2, 2s2, 2p, 2, 1s2, 2s2, 2p2. In the last shell, there are 4 electrons present in the carbon atom. So, what would be the filling of the orbitals? Suppose we have the orbital 1s2, 2s2, 2p. Orbitals are there. Electrons are filled in it. 1s, 2s, 2p, 2. Okay, 1s, 2s, 2p2. Similarly, if we take hybridization, similarly we take hydrogen. Similarly, for hydrogen, hydrogen, Z is equal to 1. For hydrogen Z is equal to 1, it would be 1s1. Electronic configuration is 1s1. So this is a 1s orbital. One electron is there. But if we see that the formation of a methane molecule, there are 4 hydrogen atoms and 1 carbon atom. So what will happen? There would be the excitation of the electron. There would be the excitation of the electron. That is also called as first excitation. That is also called as first excitation. So at the time of first excitation, what will happen? First excitation. What will happen during the first excitation? The electron from this orbit will jump to this orbit. When the electron from this orbit will jump to this orbit, what will happen? One, two, three, 4. Now we can see that there are 4 orbitals with us, and these all 4 orbitals combine, all 4 orbitals together combine to form the hybrid orbitals. 1, 2, 3, 4. 1, 2, 3, 4. These are called as hybrid orbitals. These are called as hybrid orbital. As we can see that there is one s orbital and all are p orbital, px, py and pz. So they form sp3 hybrid. sp3 hybrid. They all are sp3 hybrid. Let us understand the structure behind the sp3 hybrid. Now let us understand the structure of the sp3. Now we have here, before going to the structure part, we have here the electron of hydrogen. It will be found in opposite spin. It will be found in, if we will find that in opposite spin, so what will happen? The electron of the hydrogen, all the electrons of the hydrogen will enter the shell, will enter the subshell, and they will form what? They will form sp3 hybrid orbital. Now let us understand the geometry of the molecule. So we have understood, we know that the hydrogen methane have 4 bond, methane forms 4 bond, sp3 sp3, and they all are sigma sigma, and these all are sigma bonds. So what will happen? Let us understand the geometry of the molecule. So the geometry of the molecule. Which tetrahedral type of geometry is there? This type of geometry is called as tetrahedral geometry. It's kind of so these are all p orbitals. Then during the p orbital, 1, 2, 3, as s orbital, hydrogen, hydrogen, 1 hydrogen, 2 hydrogen, 3 hydrogen, and 4 hydrogen, and they will form the angle of 120 degree. And this is called as tetrahedral geometry. This geometry is called as tetrahedral geometry. This is the tetrahedral geometry. From this example, we are able to understand the formation of the sp3 hybrid molecule and the formation of a methane molecule, and what are the sets, what are the conditions behind the hybridization. In the next video, we will be studying about the different types of the hybridization.